Hi everyone, welcome to my workbench. Today I'm going to be covering li-poly battery charging, mostly for the smaller bots, so ant weights, beetle weights, yeah. So, the principles apply all the way up to, well, honestly, our battle bot, or the battle bot that I was involved with, Poison Arrow. But anyway, I don't have one of those packs here, but whatever. Okay, so the battery charger that I'm using that I use for like the little things is the IMAX B6 from Hobby King. It is very inexpensive. It's like $27, I think, roughly. Available from almost all of the warehouses. And then I have the power supply. I think it's this either 60 or 70 watt that just plugs into it. So that is here. Yep. So 5 amp, 15 volts. So technically 75 watt. But yeah, so it just plugs right in here. Super convenient. This is a temperature probe. It's a thermocouple, and it's not. I don't think it's included with this battery charger, but I really don't remember. And then I also have a balance board with XT60 connectors. The XT60 connector is this one. The matching battery connector is here. These are supposedly rated for 60 amps, and they'll do it. And then here I have an XT30. It's a good bit smaller than an XT60, and then here's the battery end for it. So comparison XT60 versus XT30. And the XT30 is supposedly good to 30 amps. The most I've ever done from a single one is about 20. But it held up just fine. So yeah, and then here is a JST connector. In theory, you can actually plug these in backwards if you force it. So you have to be careful there. And then the other end of that is here. Oh yeah, and a tip on these is that they're you can buy an adapter that goes from here to a servo extension, and then you want the 20 gauge. Let's see if it'll zoom in on that. Maybe not. Okay, the answer is maybe not. But anyway, so a 20 gauge silicon wire, because the ones that don't have the silicon wire are crap and they melt at about 5 amps. I know this from personal experience. They'll melt through, and then your bot starts smoking and looks disastrous. So buy good wire here, or make sure you buy like the high temperature silicon wire. It's very cheap from Hobby King, and it doesn't melt very easily, which is the real reason for using it. Anyway, so let's just charge a battery. Actually, let's go on cell counts, or cells. So this is an assembled 2-cell pack. This one is a 3-cell pack. This one is a 4-cell pack that I made by hand, which is why it looks so shady. Yeah. So 2-cell, it has 3 wires going to it. That's because the red one's hooked up to the positive lead. Black one is the negative for the entire pack, and then the white wire is the in between the packs, so that you can get the cell voltage for each pack. And then this one, 3-cell, same thing, except it has an extra wire that's blue, which means that it has 2 different basically jumper points in between, or I forget what the term is for that. But anyway, so you have cell here, cell here, cell here. The wiring diagram would have like a red wire here, the white wire here, blue wire here, black wire here. Yep. which is maybe easier to see on the other pack that I made. So here we can not really see it, but so the red wire is hooked up to this red one, blue one is hooked up to there, which is the next one in the line. The yellow wire is about midway through the pack. Orange one is hooked up to here. Black wire is hooked up to here. So the benefit of assembling it into a whole pack instead of actually assembling it into instead of leaving it as three separate cells. I mean, technically, there's not really a strong difference, assuming that you have it. So you should have fairly even cell discharges from pack to pack, from cell to cell if they're all in series. It might be a little bit different depending on the actual internal resistance of the various cells as far as discharge level when it goes. But you could actually hook them all up in parallel on a parallel charging board like this one, to where you would just hook up if you wanted to charge all the three cells separately and you left them as three separate packs, you could wire them in parallel. Like if we had an XT, like if we were using XT60 connectors, we could hook up one cell here, one cell here, one cell here. And then we would go on our charging menu here. Let's see, we're currently set up LiPo charge. We'll go to balance. Actually, this will help you learn how to operate this. So we're going to balance mode. Right now it's 1 amp, 14.8 volts, which is right for charging this pack, which is currently really swollen, and it got fully discharged and it's essentially ruined. So yeah, 3 of the cells are still good. One of them is not, and that's the one that's poofed out. But yeah, so we'll just go there. So we changed to 0.5 amp just because, and then here we can drop, oops, wrong way. Okay, well apparently I can't do balance mode. That makes sense because it's trying to balance 2 cells. So we'll just go charge mode, 0.5 amp. So nothing's hooked up here, so this isn't going to damage anything. So now we can go to 3.7 volts, and this is, and then we would hold that. It's checking connection break, means it has no battery hooked up. This is actually a good thing because it means that I'm not. Yeah, well, it basically warns you if the thing's not working right. So let's charge. I'm gonna just hook up this 2-cell pack. So first we'll just hook up this outer one. We're leaving our balance plug disconnected. So then I hit start and try to run it. Normally it gives me an error due to not having a charge. Oh, oops. It's because I'm in charge mode. Balance mode. So now let's try to do it with balance mode. Okay, again, it's working just fine. Okay, cell connect error. Good. That's actually what I wanted. I wanted it to stop. But, so now I'm going to hook up. So I've hooked it up to actually balance mode. To do balance. Oops. So 0.5 amp, 7.4 volt, 2-cell. We can see a little 2S right here. That's 2-cell mode, which is 7.4 volts nominal. Hold it down, let it start. So it's at 8.4 volts. This pack's actually almost fully charged. We can see it's 4.19 volts per cell. Fully charged is 4.20. So right now it should go almost immediately into balance mode and start trying to charge these to make them exactly on. And then we're just going to end that. Yeah. So, this is hard to undo single-handed. I'm going to have to set camera down. Yeah. low quality videos. But yeah, so that is the very basics for how we charge these packs. And then a little bit about how to assemble this. Oh, that reminds me. So the easiest source, in my opinion, for these JST connections that are pre-wired, nice, is to just grab a bag of extensions. These cost about $4 for 10, so 40 cents a piece. Not horrible, especially if Hobby King doesn't actually sell what you need, which is the case for this. My 450 packs that are for sale that I use in Project Darkness. They could also be used in like Super Veloce or actually all of my Beetles, but just Project Darkness essentially. Yeah, I think that's it. Have a good one. Hopefully I didn't... Oh, and then the side of this charger actually uses banana plugs, and then it has separate terminals for each connection. I'd recommend having this separate big board, because they're like $8 from Hobby King. They're pretty cheap, and it's just easier to plug everything in when it's over here and like all spread out. Plus it allows you to balance to parallel charge. That said, that requires more, you have to care a little bit more about what you're doing and like mentally keep track of what you're doing a little bit more, and just to make sure that you're not going to screw it up. But yeah, parallel charging is a thing, and it can allow you to charge, well, technically like an infinite number of battery packs, but I feel like once you wire that all up, you'll probably have some problems with like actually measuring resistance drop due to just the sheer amount of cabling involved, but theoretically possible. Of course, it's also practically impossible to have an infinite number of cells, so infinity. Long spiel. All right, well, have a good one. Bye.